Hello, today I'm looking at this. It's the Junctek battery monitor, model number BL105F. And this is a coulometer, it says it there. So it counts the movement of charge. It's bidirectional, so typically you'll use this to count the movement of charge into a battery and also the movement of charge out. And by counting it in both directions, it can keep a state of charge indicator, which you can see there. So 85% battery state of charge. So let's have a look at what's in the box. And it's this. There's the display unit, which is this thing. I can't remember what size the display is. It's a 1.8 inch, I suppose that is, high definition LCD color screen. Now I shouldn't forget the quick guide, which is also in here. That's the positive connector, because you need to be able to connect this sampler unit to battery positive. So this is, I believe, the 50 amp sampler. You can get this unit with different size samplers. I'll just check that out in the manual. Yes, this is the 50 amp sampler unit. You can also get from 100 amps up to 400 amp sampler units. They look slightly different because they're physically bigger, because they've got the higher current shunt on the unit there. Also in here is a very long and actually quite fat cable. It's 6 pins. Interesting how they've sort of put silicon sealant on there. I must admit, after looking at this, I did think actually they'd probably get on better with a connector that is 3x2 rather than 6x1. You wouldn't have this splaying of these connectors. But anyway, this cable links the sampler unit on that connector there to the display, which also has a 6x1 connector on it. There's also this metal bracket here, and that goes on the wing nut on the back, and it's designed so that you can put this into a panel aperture, and then this just holds it in place behind the panel. That's shown here in the manual, but there are other options for this, and they look like they're designed to fit on handlebars of a bicycle, or you can get this optional holder. I went for the basic panel mount bracket. Actually, I wish I'd gone for something a bit more versatile now, like this one here. Right, now I need to attach this to a battery. So I've got this, it's a 4S2P, using cells that were left over from the big battery in the shed. And I've already mounted to this a little 4-way display so that you can see the voltages of the 4 cells. I've set this display to just stay on for 15 seconds so it doesn't drain the batteries down. So we're at 3.3-ish volts per cell. There's a bit of difference here. There's no balancer on this. It's just the 4 cells in series and my little voltage monitor thing there. Okay, let's add some hardware to this so that we can attach the Junctek BL105. So I've made up this piece of wood here with brackets and bits and pieces on it, and I'm going to attach that onto the back here. The display goes on that bracket, and then the cabling fits on the back, and the sampling unit fits on the front here. So let's get that screwed into place. Okay, the display fits on the top of this bracket here. Attach that like so, and now I can peel off this protective sheet from the front of the display. Good. Right, the sampling unit can go here on the front, and then I'll hook all the cables up and get some power from the battery into the sampler. So all you need to do is connect up B-, which is here, to the negative of the battery, my black connection there, and the little connector there is pos, and that will go across to red up here. So the display is connected to this cable, the other end goes into the sampler here, and then I've got some bits of cable I've made up here to go onto the current shunt, and they just end in banana sockets. Right, B minus is this connection on the left, so that needs to connect to the negative side of the battery, which I'll do like so. The positive connection, this yellow wire, I've put on the little screw terminal there, so that needs to connect to the positive of the battery, which I'll do with this yellow wire. And now the display comes on, and you can see that it shows volts, 0 amps, because of course there's no amps flowing through that shunt. It doesn't indicate in any way its own self-consumption. But let's get in a bit closer on that display. So there are a number of displays, as you can imagine. This one has volts of the battery and amps flowing through the shunt, and the state of charge of the battery. Now, it doesn't know what the state of charge is. You have to tell it. Currently, there are no watts, of course, because there are no amps. And we have an amp hours counter, which we can presumably zero out. And we've also got time. Now, this is time remaining. So at current, as it were, at the current rate of energy usage, this is how long the battery will take to go down to 0%. And we just cycle through those three screens with either the left or right button. Now, if you press and hold, you can set the current battery level. So if I, so that's the little edit marker there. If I say I want this to be at 50%, I have to tell this unit that I think the battery is at 50%. That comes out of editing, press and hold OK, and we go back to this screen, and so now it just simply says we are at 50%. The other one that you can press and hold is the battery amp hours. Now, I happen to know that this set of cells, the top 4 cells are 6 amp hour cells and the bottom 4 are 6 amp hours. So we've got 2 in parallel and then 4 in series. So this is a 12 amp hour battery, so I can put that into the coulometer. So let's go into edit. The little marker there says edit. I can move, I can up and down that field. I don't want to do that field. I want to do this field and take it up to 10, do that field and take it up to 12 amp hours. I can't remember. Can I press and hold to come out? Okay, so now we can see, where is it? 0.1 amp hours remaining. Yes, that's because it's gone to 0%. So I need to edit the percent field again, take it up to 50%. And we now have amp hours remaining as 6, because I've told this unit that the battery is at a 50% state of charge. It knows it's a 12 amp hour battery, so it says there are 6 amp hours remaining. So now what I want to do is start drawing some current from the battery so that we can see some amps on this display. So I've got this car headlight bulb. The 2 filaments are wired in series, so it won't take the full 50 watts at 12 volts. But let's now connect this to the other side of the shunt, which means that any power going into this bulb will go through the shunt in that direction. So we should see the percentage indicator come down. But anyway, let's connect that up. So the voltage of the battery falls a little bit. We've got 3.4 amps of current. We can take a look at the other fields, which are watts. We've got 44 watts. It's counting up amp hours. No, it's counting down amp hours, because that's amp hours remaining in the battery. Now, of course, this unit has no idea whether there are that number of amp hours remaining in the battery. And in fact, what we can do is we can say, actually, we don't want to use the entire 12 amp hours of the battery, because one thing I don't want to do is have my cells, any one of them go out of spec. So what I could do is I could say that this is only a 6 amp hour battery and we'll just use half its capacity. So can we do that while it's actually got current being pulled? Press and hold OK. So that's configuration. Actually, I don't want to do that. I want to press and hold the amp hours of the battery. I want to edit that, move. No, I don't want to do that. I want to move to the field for 6 amp hours and put that up to 6. OK, that. No longer editing. Press and hold. Now I want to say that we're at 50%. So press and hold percentage. Edit that and come up to 50%. It immediately drops to 49 because we're under load. But now we are at 50% of a 6 amp hour battery, so we've only got 3 amp hours remaining. And so now this unit is only using a window of the battery's total capacity, and it will count down to 0%. Well before the battery is actually discharged, and similarly if we charge the battery it'll count up to 100% well before it's fully charged. We're just using a smaller proportion of the battery's total capacity, and this unit is going to work within those bounds. And in fact the only real connection we have to reality, what's actually going on in the battery, is this voltage. That's the only thing that really tells us where we are in the range of the battery, because I could move this percentage simply by editing the percentage field in this unit, and we could shift it down in the battery's capacity or we can shift it up. I just happen to have set it so that it's round about the middle, but the only feedback I've got on that is the fact that the battery is at 12.8 volts. Okay, so that this thing moves a bit quicker, let's actually press and hold that. Let's say that we got a 1 amp hour battery. Move to the field and bring that down to 1 amp hour. Stop editing and go back to the display. So now we've got a 1 amp hour battery. I'll connect up the light bulb to it's the right hand of these two terminals here. And now it'll start counting down much more quickly because we only have 1 amp hour remaining, and you can see it counting down. And in fact, because it's a 1 amp hour battery, the percentage and the amp hour indicators are kind of on the same number, so it'll now drop to 97%. Okay, let's see what happens if I edit the percentage field and bring that right down to say 10%. Okay, that. Okay, the indicator turns red because it's saying you're at a low state of charge. Now, of course, again, we're within a tiny window within the battery's 12 amp hours of total range. I've told the coulometer we only have 1 amp hour to play with, and it's right down at the bottom of that 1 amp hour range. But I want to see what happens when that gets down to 0%. So the coulometer has now counted us down to 1% battery remaining. That also is shown on the amp hours remaining there, and it's also shown as time remaining, although that's hit 0. But amp hours remaining now is going to go down to 0. And then what happens? It doesn't go negative, it just stops. We're still pulling 43 watts, and we can still see the voltage of the battery. But the coulometer, as far as it's concerned, because this is only a 1 amp hour battery, has got to 0%. But what's happening now is that 1 amp hour window is actually moving down as this voltage of the battery pack comes down. This is lithium iron phosphate, so you're not going to see much movement in the voltage in this center range, because we are about in the center of 12 amp hours. We're probably sitting at about 6 amp hours, but the coulometer has been told completely different numbers to that. So this coulometer has no individual cell monitoring, so of course we can't see what's actually happening with the cells. At 12.8 volts we can be fairly certain that the cells are fine. It has no relay, so that when it hits what it thinks is 0% state of charge, it doesn't switch off the load. You can see we're still pulling 3.3 amps. So all it's doing is measuring current that's going through the shunt and winding a little counter up and down within the limits that we've set. And when it gets to 0, it just sticks at 0. But of course, actually, the battery is discharging now. So the 0 point is actually moving. And similarly, if we were charging, the 100% point would be moving. Now let's just go through some of the other menu options. So if I press and hold that, we've got language, Chinese and English. We've got carousel. Now all carousel does is the 3 screens where you had volts, amps as one screen, watts and amp hours as another, and remaining time as the 3rd screen. You can have it go round those automatically, a couple of seconds per screen, that sort of thing. Invert display, I can't quite remember what that is, but let's put it on. Oh, it just changes all the colors, so whites become blacks and some colors become different colors. I think it helps in night mode, something like that, but actually we'll go for that. What else is there? Auto screen off. Yes, you can have this device cut the screen off, but it's still drawing power because of course it still has to be counting those coulombs. Amp seconds are what coulombs are, although this displays it as amp hours because it's a more useful unit. It's still counting those, so the microcontroller is still running. We'll take a look at the current consumption in a moment actually, and the brightness of the screen, which is currently on 50%. Restore defaults, so it will reset the amp hours to whatever the default were. I can't see that being terribly useful actually. And back to language. So there's a small set of parameter adjustments, but what this unit doesn't have is any sort of voltage trigger. So on some coulometers, what you can do is you can say if the voltage hits a low point, like in this case, say 10 volts, set it to 0%. And if it hits an upper voltage of say 14 volts, force it to 100% so that it resynchronizes the position of this Coulomb counter based on what it's seeing on in voltage terms. Now this unit doesn't have anything like that. Press and hold OK to return to the main screen. Yes, the colours have changed, haven't they? Quite significantly. We've got a white background and various dark colours on that white background. Now note also that this is a Coulomb counter. It doesn't count joules, so it doesn't count watt seconds. Although the voltage is displayed, it doesn't actually use it in any of its calculations. So the only thing you get to see are amp hours, but there are no watt hours, which are a equivalent of joules. Joules are watt seconds, so watt hours would be multiplied or divided by 3600. And it's the same with coulombs. Coulombs are amp seconds, so amp hours are the same as coulombs, but with a factor of 3600. Right, I've now put an ammeter in the power feed to this unit to see how much power it's drawing, and you can see that it's 38 milliamps. Just turn that meter out. No, I can't. I've also set the display to timeout after a period of time. It's the auto timeout. I think we'll have a look at that in a minute. And that goes from 38 milliamps down to 12 or 13 milliamps. So even if you have the display automatically switch off, it's still drawing 12 milliamps. So you probably wouldn't want to leave this unit connected overnight because it's drawing a significant amount of current. So the auto screen off is press and hold that, carousel invert display. Auto screen off, it's very simple. You just move it from off to on or back to off now because I don't want it auto screening off. So let's get out of that. And now the display will stay on and this unit will continue to draw about 38 milliamps continuous. So let's now try charging the battery through the coulometer. So I've hooked up this to this power supply, positive to positive, but negative is going through the shunt. So let's switch that on. I've set it to 3.5 amps, which is about what that bulb was taking. And now we can see that the voltage of the battery is pushed up, of course, because it's got this positive current. You can see the symbol there has gone to positive and it's saying charge. Previously there was a minus there and dis for discharge, and we can see that the percentage indicator is counting up, and on the other screens we can see how many watts are going into the battery, and of course now we've got a positive amp hours count as charge is going into the battery. What else can we see? Total time to charge the battery. Now remember, this is set so that it thinks this battery is just a 1 amp hour battery, so it says it'll take 15 minutes to complete the charge to 100%. So in summary, yes, this is a very simple, easy to use coulometer, this battery monitor, the BL105F. It's all manually set. You decide the amp hour size of the battery, you decide the current percentage where you think the battery currently is in its percentage range. Although voltage is displayed here, so you get an at a glance hint as to where you are within your voltage range. Of course, I'm just checking with my little cell indicator here to make sure no cell is going over voltage. This voltage is not used in any of the calculations, so there's no, well, it is used for the watt meter, so you can see how many watts are going through the shunt, but there's no watt hours field, and there are no trigger points. So when you get to a certain voltage, either upper or lower, there's no ability to have it force the unit to push it to either 0 or 100%, or indeed a voltage trigger that would force it to hit 50%. Although, of course, with lithium iron phosphate, it's very difficult to know where 50% is, because the central portion of the graph is very flat and only now that we're charging, only pushes up at the end or drops down at the beginning. So yeah, lithium iron phosphate, very difficult to know where you are within the range of state of charge. So I will put links to this unit, the BL105F coulometer, in the description below the video so that you can see where to obtain it. But for now, that's kind of it for this video, so cheerio.